Paris, France. A warm summer afternoon. On runway 26, ground crews are preparing Air France Flight 4590, a Concorde scheduled to fly from Paris to New York. On board are 100 passengers and 9 crew members, bound for New York in barely 3 hours. Just moments after takeoff, tragedy strikes. A stray metal strip on the runway, dropped by a DC-10 minutes earlier, goes unnoticed. At over 300 kilometers per hour, Concorde's tire hits it, shreds, and debris rips into the wing, rupturing a fuel tank. Flames engulf the aircraft. Engines fail. The nose rises, but the jet can't climb. Just 2 minutes later, it crashes into a hotel in Gonesse. All 109 on board and 4 more on ground are lost tragically. It was the first and only fatal crash of the Concorde, but it was the end. Concorde, the skybound icon, was grounded. At the time, supersonic dreams didn't fade. They were buried deep in history. And now, the future of supersonic flight has taken a monumental step forward. After more than 50 years, the U.S. government has officially lifted the ban on supersonic flights over land, once restricted due to concerns about disruptive sonic booms. This historic move signals a new era, encouraging innovation in quieter, more efficient supersonic technology that can finally soar above cities without disturbance. With new noise certification standards focusing on community acceptance and technological feasibility, companies like Boom Supersonic are positioned to lead the charge, turning bold concepts into commercial reality. Today, a new hope has risen. What seemed impossible in the aftermath of the fatal crash now seems achievable, if all goes according to plan. Supersonic travel has risen again with the recent advancements by an American company, Boom Supersonic. Founded by Blake Scholl, who is rewriting the rulebook. Their vision? To bring supersonic flight back, faster, cleaner, and more accessible than ever before. This time, the world is more eager to hear the sound of a boom again, not from the past, but from the future. If we dive into the recent developments, we see that in early 2025, a jet named XB-1 Demonstrator, or better known as Baby Boom, a 1/3 scale prototype of the planned Overture airliner, roared over the Mojave Desert at an altitude of 35,290 feet, piercing the sound barrier at Mach 1.12. It became the first independently developed civil aircraft to do so. This test flight proved Boom's Overture aims to address the limitations of the Concorde by incorporating modern technologies for improved efficiency and sustainability. The aircraft is designed to cruise at Mach 1.7, carry 64 to 80 passengers, and operate on 100% sustainable aviation fuel, with a focus on reducing noise pollution. Despite these achievements, Boom faced challenges typical of pioneering aerospace projects. Boom Supersonic's ambition to redefine air travel has attracted significant investment from a diverse group of backers. As of late 2024, the company has secured over $700 million in funding through various routes. This includes a $100 million Series B led by Emerson Collective in 2019, a $50 million Series C in 2020, and a $100 million funding round in December 2024, featuring investors like Sam Altman and Reid Hoffman. Strategic partnerships have further bolstered Boom's financial position. In 2023, the NEOM Investment Fund, the strategic investment arm of Saudi Arabia's NEOM development project, made a strategic investment, bringing total funding to over $700 million. Despite strong investor confidence, Boom has faced significant challenges, especially in securing a major engine manufacturing partner. Initially, they partnered with Rolls-Royce to develop the engine for Overture. But in 2022, Rolls-Royce withdrew from the project, citing shifting priorities and the immense technical challenges of building a supersonic engine that meets modern efficiency and environmental standards. This was a major setback. Engine development is one of the most complex and costly parts of designing a supersonic jet, and having a world-class manufacturer on board is critical. Undeterred, Boom shifted gears and began developing its own engine, called Symphony, in collaboration with Kratos Defense and Security Solutions, a company known for advanced propulsion systems in defense applications. Building an engine from scratch is no small feat. It requires vast resources, cutting-edge technology, and years of testing. This has put additional pressure on Boom's funding and timelines. The company must balance innovation with financial discipline, navigating delays and technical risks while maintaining investor confidence. To understand how bold this journey truly is, we need to look back at the cost of ambition. The Concorde program, jointly developed by Britain and France, costed over £1.3 billion by the time it entered service in 1976. That's equivalent to over $13 to $15 billion today, adjusted for inflation. And despite its elegance and speed, only 20 Concordes were ever built, with just 14 entering commercial service. The cost per aircraft? Over $200 million in today's money, for a jet that could barely break even with premium ticket prices. Now fast forward. Boom Supersonic's Overture is being developed with a much more strategic, scalable approach. Their estimated program cost is around $8 billion, nearly half the Concorde's adjusted price tag. This time, Boom isn't relying on government funding or national prestige. Instead, they're backed by private capital, strategic investors, and aircraft orders from major airlines before the plane has even entered commercial service. Their target is to get production around the $200 million per unit mark, comparable to a modern wide-body jet like the Airbus A350. Also, when we look into the delays in the XB-1's development, most of them were attributed to the complexities of supersonic aerodynamics and the integration of advanced materials like carbon fiber composites. Traditional supersonic aircraft like the Concorde used a drop nose to enhance pilot visibility during takeoff and landing. Boom's XB-1 replaces this with a forward-looking vision system, using redundant cameras and multifunctional displays, giving pilots a virtual view of the runway while avoiding the added weight and complexity of mechanical systems. The XB-1 underwent 3 sets of wind tunnel tests to validate its design. Initial tests revealed a 30% discrepancy in predicted calibration, which was corrected in subsequent tests, confirming the aircraft's aerodynamic stability and safety. Boom has achieved a lightweight yet strong airframe, essential for efficient supersonic flight. These materials allow for precise aerodynamic shaping and contribute to overall fuel efficiency. If we look back at Concorde's downfall, it wasn't just the crash. Deafening sonic booms, especially in places like the UK, sparked outrage as they rattled windows and nerves. Environmental concerns grew louder too. Concorde dumped fuel mid-flight over oceans, alarming climate activists and aviation watchdogs alike. It was fast, it was iconic, but it wasn't sustainable to carry the future of supersonic travel. To tackle the biggest issue, immense noise pollution, Boom Supersonic is doing what Concorde never could, redefining supersonic travel from the ground up. Learning from the past, Boom's engineers have addressed many of the design flaws that once held Concorde back. One of the most important upgrades is the shape itself. Overture's fuselage follows the principle of area ruling, a technique where the body subtly narrows and widens to smooth airflow at transonic and supersonic speeds. The results are reduced drag, smoother flight, and more efficient cruising. It's a solution to one of Concorde's biggest aerodynamic challenges. Then there's the engine layout. Unlike Concorde, which had 4 noisy engines under its wings, Overture places its engines along the rear fuselage. This offers 3 key advantages: reduces cabin and ground level noise, improves wing aerodynamics for better fuel efficiency, and simplifies airflow management across the aircraft. The innovation doesn't stop with structure. Overture will fly on 100% sustainable aviation fuel, made from sources like plant-based oils, waste biomass, and even captured carbon dioxide. This means up to 80 to 90% reduction in life cycle carbon emissions compared to conventional jet fuel. No reliance on fossil fuels. A cleaner, quieter ride at the edge of the atmosphere. The Concorde may have sparked the dream, but this time the world is ready to catch it. From New York to Tokyo, Dubai to London, the demand for faster, smarter, and more sustainable travel is rising fast. And Boom Supersonic is leading that charge. United Airlines has already ordered 15 Overture jets, with options for 35 more. American Airlines followed with 20 firm orders and 40 on standby. Japan Airlines holds 20 as well. Virgin, and others yet to be named, are watching closely. In total, more than 130 orders and pre-orders, nearly 10 times the fleet size of the Concorde. Governments and aerospace innovators from Europe to Asia aren't just eyeing supersonic travel for commercial routes. They're circling for something more: VIP transport, defense strategy, and diplomatic power plays. Why? Because time is the new currency. New York to London, under 3.5 hours. San Francisco to Tokyo, just 6 hours. LA to Honolulu, a breezy 3 hours. All while offering business-class economics instead of Concorde's luxury-only model. A recent survey revealed that 97% of premium travelers would switch for supersonic, and even 87% would leave their current airline to experience it. Analysts now predict a $70 billion market by 2034, with demand for over 1,000 aircraft and 600 profitable global routes. But we can't overlook the challenges that Concorde faced. Till date, supersonic travel has faced many challenges, from noise and fuel efficiency to safety and sustainability. But with breakthrough innovations and relentless determination, Boom Supersonic is tackling these obstacles head-on. Personally, I'd be thrilled to experience the future of supersonic travel myself. The journey is just beginning, and the future of flight is taking shape before our eyes. If you enjoyed this video, don't forget to like and subscribe to our channel for more awesome aviation content. For daily aviation content, behind-the-scenes insights, and all things that make this niche amazing, follow us on Instagram at @aviatorsbird. Thanks for tuning in. See you in the next vlog.